Hey everybody, the purpose of this video is to get you some solutions to the Bend, Oregon snowfall on February 8th, 2014 and its effect on the overall average on February 8th, 2014. So it's pretty fun. It was funny as the snow was falling that day and I was shoveling out myself, my neighbors, my in-laws and everybody else. I had the idea this will be a super fun quiz to talk about. How is the average changed because of this goofy snowfall? Like, how much is it going to go up? And it's funny because one of your classmates actually had the exact same idea and emailed it to me, and a few hours later, I was defrosting, I got the email, so at least one other person was thinking about it. Anyway, the first data I had was gotten from, this is all from the Western Regional Climate Center. They say that the average snow depth, mean snow depth, 2/10 of an inch from 91 to 2013. 91 to 2013, so that's what? That's 20, how many years is that? 23 years. 23 years in that range. So it's 23 years in that range at 0.2 inches on average. On average. I want to do the calculation first and I'm going to show you why it's valid here in a minute. Then you have to recalculate the average now with our new data of 25 inches in 1 year, 2014. So this is from 91 to 2013. So I gave you a hint to use a weighted average. The weighted average is going to look like this. You have to do the data, which is 2/10 of an inch, times the number of times to count that. I want to talk about this and why it's valid momentarily. Plus the new data, which is 25 inches, times its weight, which is only 1 because it happened 1 year, over the 24 total years of record from 1991 to 2014. So you've got 23 and the 1 year make the 24. So this becomes a GPA problem. You've got a certain class that's worth 23 credits and one class that's worth 1. What's your GPA? And that's a terrible example because this doesn't exist, but it's the same mathematics. It's the same mathematics. This ends up being 1.2 inches. And I love that because that means, and it makes perfect sense when you think about it. When you add 25 inches into this measurement, it raises the average from 2 inches to 1.2 inches. And if you think about, I'll give you two ways to think about this. Number one, when you think about the first couple weeks of class, and I had the lollipop example where I gave everybody lollipops, and I said, what's the average number of pops? It's the sharing, equal share measurement. So what you'd have to do is take these 25 inches and distribute them evenly across all of these 23 years. So essentially, you're taking an inch off of the 25 and giving it to 1991. This is now 24. Take another inch off of that, give it to 1992. This is now 23. Another inch off of this and put it on this. This is now 22, 20. And eventually, once you give all those inches away, this is now down to about an inch, or 1.2 inches, I guess. And these are all 1.2 inches. So it averages out to 1.2 inches. So it makes perfect sense when you think about it from the share mentality. That's why I never force formulas on you guys. When you think about this as a pure share, it's much, 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 much simpler to think about. Now some students don't like this. They don't like this 23 times 0.2 because they say, how can that... What you have to do is you have to have all the snow divided by how many years. And that's correct, but this is an amount of snow. This is the total amount of snow over these 23 years that fell. And some people say, how can you know that? Well, here's how. In order to calculate an average, you have to sum up all the data and divide by how many data points there are. Hopefully that makes sense to you. So you would divide by 23, and you'd sum up the snow, and that would be the average of 0.2 inches. So think about that. If you solve this for the summation of x, you get n times x bar equals the summation of x. Now break it down with me. N would be number of years, n is 23. X bar would be the average, that would be 0.2 inches according to the WRCC. The summation of x would be the total amount of snow that has fallen in those 23 years. It doesn't tell me how much snow fell on any given year. It just tells me that that amount of snow fell over those 23 years. Make sense? Good. So, you got that amount of snow, and I don't know what that ends up being. It ends up being, you know, what's the fifth of 24 plus some change, 4.3 plus 25 divided. It doesn't matter. It averages out to 1.2 inches over that time period. Boom. Make sense? Hopefully it makes sense. The second part is exactly the same calculation, except it's done It's done on a larger database from, looks like it's 78 years. Okay, 78 years. And it looks like the average over that entire time, and again, this is directly from the chart, I called it 0.75 inches. So now you're going from 1928 to 2005. So I'm calling the average 75 hundredths, and we're going to multiply that by 78, plus our original 25 inches that we got on the 14th. That's going to give us 79 total years. And I crunched that one over here, and I got about 1.1 inches. 1.1 inches. So it's interesting. Even though the higher, well, it's not interesting, it's actually a consequence. The higher average total was 0.75, so the 25 inches doesn't affect it as much as it did over here. Because over here, there was a much bigger disparity between 0.2 and 25 than 0.75 and 25. So in other words, you don't have to share quite as much of the 25 across to each of these to make them even, because these are a little bit larger. They're about a half an inch bigger or so on average than the other one. The other average was. So the idea is that this idea of a weighted average, and right now in class, I'm not exactly sure when you guys are watching this video, but in 2014 in class we're talking about the averages of probability distributions. Probably the most important idea of the entire course. But it all stems back to this. It all stems back to finding averages. You can calculate these averages the wrong way, of course. You could do 0.2 plus 25 divided by 2 to get something like 12.5 inches. Well, 12.5 inches would be correct if you were looking at the average snowfall between last year and this year. And the snowfall we got last year was 0.2 inches. I mean, that would make perfect sense. Absolutely perfect sense. But that's not what happened. It's 0.2 of an inch over 30 years, and it's 3/4 of an inch over 80 years. So you have to account for those weights in the average. And every average can be viewed as a weighted average if you look at it a certain way. So, hope it helped.